All right, we're going to continue with the next two examples for lesson 2.3. We have triangle XYZ with the measure of angle X equal to 25 degrees, and side Z's measure is 9, and X equal to 6. So triangle XYZ, angle 25 degrees, side opposite Z measures 9, side opposite angle X measures 6. This is a pattern of givens in the form of SSA, side-side angle, because the angle is not where the two sides meet, not in the middle of them, but rather the side is in the middle. All right, so that means we're going to use the law of sines. We may have 0, 1, or 2 solutions. By the way, we'll always assume that we have 2 solutions, and then we'll see if that actually bears out. All right, so to set up the law of sines, we need to start with the sine of angle Z divided by the opposite side measure 9 is equal to the sine of 25 degrees divided by the opposite side measure 6. If we just multiply both sides by 9, sine of angle Z is equal to 9 sine of 25 degrees divided by 6. And measure of angle Z is equal to the inverse sine of 9 sine 25 degrees divided by 6. Now we know that when you solve an equation involving sine for an angle that's between 0 and 180 degrees, you get 2 solutions, assuming that sine is equal to a positive number, because sine is positive for angles that terminate in quadrant 1 when drawn in standard position, and also in quadrant 2. The calculator will give us the quadrant 1 angle. So let's enter that. The inverse sine of, control divide for a fraction, 9 times the sine of 25 degrees divided by 6. And that's going to give us an acute angle. So measure of angle Z could be 39.340. I'm going to write this over on the left side, and then I'm going to use a column here on the left side to represent the first solution. And then we'll write a second solution over here on the right. So I want to start with what the measure of angle Z could be for our second solution, and it will be the supplement of that angle. So I'm just going to write that calculation there. We'll come back to that. What I'm going to do first is just solve all the way through for the first solution. So I'm going to resketch now. I'm going to resketch my triangle XYZ with my 25-degree angle, my side of 9, and my side of 6. That matches. And now our newfound second angle, angle Z, is 39.340. The easiest thing for us to find next would be the third angle. So the measure of angle Y is equal to 180 minus 25 minus 39.340. When we do this calculation, we want to make sure that we are bringing all of the decimal places with us and not just typing 39.340 into the calculator. So 180 minus 25 minus, and you could use the answer feature here if you want, or you can cursor up and grab that 39.340. When you do so, it'll bring all the decimal places with it. So that gives us 115.660. Degree symbol if you like. I'm going to box that. I'm also going to write it into my diagram so that we can investigate it for seeing if this answer makes sense. And we have one thing left to find, and that would be the side opposite angle Y. In order to do so, we need to use the law of sines again. So that would be sine of 115.660 divided by Y, the measure of the side opposite angle Y, equals, and I'm going to use 25 degrees and 6 for my other proportion because I don't want to have to worry about a rounded answer. We do have one rounded answer already in our calculation, just easier if we don't have to use both. So now let's cross multiply. Y times the sine of 25 degrees equals 6 times the sine of 115.660 degrees, if you like. And then y is equal to 6 times the sine of 115.660 divided by sine of 25 degrees. And then we can just put that number into the calculator. When we do so, control divide for a fraction, 6 times the sine of, and here I'm about to use an answer that has been rounded off. So I'm going to go grab that calculation, cursor up to grab that number there, and bring that down. And you'll notice when it brings it down, it brings all the decimal places with it. Downstairs, the sine of 25. Enter, that's 12.797. It won't always work out that it matters whether you bring all of those decimal places with the calculation, but it can. And so if your answer is off by a little bit, you'll get a deduction for accuracy. So we want to make sure that you are using the answers that are stored in your calculator. All right, there's our first solution. Let me go ahead and put that last measure into our triangle, 12.797, and then I'm going to investigate that for sense making. Our largest side, 12.797, is opposite our largest angle, 115.660. Smallest angle, 25, is opposite the smallest side of 6. So seems pretty reasonable. All right, let's go and figure out what our second solution is. And this is maybe the hardest thing to remember with an SSA case. You always have to remember that there's the possibility for a second solution. And you must acknowledge that the second solution could possibly exist. All right. So the first thing that we find in solution 2 is the measure of angle Z, which is the supplement of the first angle Z that we found. So I'm going to start with that calculation, 180 minus, and cursor up to grab that 39.340 for accuracy's sake, and we get 140.660. So measure of angle Z is 140.660 degrees. I'll box that answer in. I am going to make a diagram and put all of our given information in there. 25 degrees, 9, 6, and then insert our calculated result of 140.660. And now there's the easiest thing for us to find next would be the third angle. So the third angle, angle Y, would be 180 minus 25 minus that 140.660. When we do this calculation, it's important that we grab that unrounded answer. So 180 minus 25 minus, and then go up and grab that number and see that it brings down the unrounded version of that number. Press enter. Measure of angle Y is equal to, looks like we've got 14.340 degrees. There's our third angle. One thing left to find. I'm going to go ahead and insert that in the diagram so that we have that relative positioning for future reference for our next calculation. And the last thing to find is side Y. So to find side Y, we need to have sine of the angle that we just found, 14.340, divided by Y equals sine of 25 divided by 6. And cross multiplying, Y times the sine of 25 degrees equals 6 times the sine of 13.340. And Y is 6 times the sine of 13.340 divided by the sine of 25 degrees. And now we need to enter that computation into the calculator, being careful to enter the unrounded version of 13.340. So 6 times the sine of And well, that was 14.340, wasn't it? Okay, so we're going to change that. My eyes are not as good as they used to be. And so that would be 6 times the sine of the previous answer. You can use the answer feature if you like, or you can just paste it in by clicking up and grabbing that number, then divided by the sine of 25. Press enter, 3.516. And then I'm going to insert that into our diagram, and we're going to talk about sense making, 3.516. And indeed, that smallest angle, 14.340, is opposite the smallest side, 3.516. Largest angle, 140.660, is opposite the largest side, 9. So this answer makes sense. So we've got it organized so that I can find where is my first solution in the left column, where's my second solution in the right column. All right, next we're going to take a look at an example of an SSA. And again, we're going to assume that we have 2 solutions until we find out maybe that we don't. So we have a triangle PQR. Measure of angle P is 29 degrees. Side P, or the side opposite that, measures 19. The side opposite Q measures 15. This is a pattern of givens that fits the SSA. That's the ambiguous case, and that means that we can solve this triangle, but we may get 0 solutions, we may get 1 solution, we may get 2 solutions. We just don't know when we start. So I'm going to start by setting up the law of sines. Sine of 29 degrees divided by opposite side 19 equals the sine of angle Q divided by opposite side 15. And let's multiply both sides by 15. So sine of angle Q is equal to 15 sine 29 divided by 19. And measure of angle Q is the inverse sine of that expression. And we really do need to show all of these steps, so be careful that you are showing all of this work on your paper as well as in your calculator. Next, we need to enter this into the calculator, and remember, sine is ambiguous when solving for the angle. If we are looking for an angle that's somewhere between 0 and 180, if sine is a positive number, then there are going to be 2 solutions, one acute, one obtuse. Calculator will give us the acute value. So sine inverse of control divide for a fraction, 15 times the sine of 29 divided by 19, and that's going to give us the acute angle 22.504. So measure of angle Q is equal to 22.504. I'm placing this solution over here on the left side, reserving this left column for our first solution. Now I'm also going to recopy this diagram and insert this value in there and proceed down with the rest of the first solution. So PQR 29 degrees, 15, 19, and now we found a second angle. Measure of angle Q is 22.504. And next, the easiest thing to find would be the third angle. So our third angle is 180 minus our other 2 angles, 29 and 22.504. Now that we're going to do that calculation, 180 minus 25 minus, and realize that we have a rounded answer there. So I'm either going to go up here and grab that number or just use the answer feature, whichever one's easiest. That'll give us our third angle, which is angle R, actually is 132.496. I'm going to change this. It was not angle Q that we were finding, it was angle R. And so measure of angle R is 132.496 degrees. Now we have just one thing left to find. I'm going to go ahead and insert this into the diagram. And the one thing left to find would be the side opposite that angle. So sine of 132.496 divided by the unknown side r that is opposite angle r equals sine of 29 degrees divided by 19. And remember, you can use whichever angle you want for the other pair, but I like to use the one that hasn't been rounded so that I don't have to worry about my accuracy. Let's cross multiply. R times the sine of 29 degrees equals 19 times the sine of 132.496. And r is equal to 19 times the sine of 132.496 divided by sine of 29. And now we just need a decimal approximation. Control divide for a fraction, 19 times the sine of that number that came before. So use the answer feature maybe, control negative, and then divided by sine of 29 degrees. And that'll give us 28.896. I'm going to insert that in our diagram. And then try to make some sense out of it. That is the biggest side in the triangle and its opposite angle r, which is the biggest angle. Our smallest side 15 is opposite the smallest angle 22.504. So first solution done. Makes sense in terms of small sides being opposite small angles. And now we're going to go back and grab the second solution, which I should have probably written something, but remember, in SSA, the first angle that you find, there are two solutions. Calculator only gives you one. So in our second solution, measure of angle Q would be 180 minus the answer that we got for angle Q in the first solution. So measure of angle Q is equal to 180 minus, and the measure of angle Q that we got in the first solution was 22.504. So I'm just going to go grab that from a previous calculation on the calculator, and it will bring it down with all of its decimal places so that we don't have an accuracy problem in our second solution. And press enter. That gives us 157.496. So there's our first part of the second solution. I'm going to recopy our diagram, P, Q, R, insert the given information, and then insert the first angle that we found in solution 2. So our first angle that we found in solution 2 was measure of angle Q is 157.496. Now remember that once you have two angles, the third angle is very easy to find. So measure of angle R would be 180 minus the 29 degrees minus the 157.496. Let's do that calculation. 180 minus 29 minus, and I'm going to use the answer feature, or I'm going to grab that from a previous calculation on the screen. And lo and behold, measure of angle R is equal to negative 6.496. Now, I want to actually see this computation on your paper, not just necessarily your calculator. And what happened? We got a negative angle because of the fact that the previous two angles, the given and the one that we found, measure of angle R, added up to more than 180 already, so the third angle wasn't really possible. So what does this mean? It means that there is no second solution. So when you're solving an SSA, we're always going to assume that there's two solutions unless we get no solution at the very beginning. And if we get into our second solution and we find that the third angle is negative, that's going to be our indicator that there is no second solution for this particular case. So that has to be acknowledged rather than just leaving it at one solution with no work shown. And that's it for the lesson.